school statistics and the probability. First, let's think about what is probability. Probability is to predict the chance of the event. Okay, we cannot predict next event, and in the nature, there are many things are like that. Well, Newton's law tell you exactly where the object is after a certain time. That's called deterministic world. But unfortunately, our world is not deterministic world. As quantum mechanics shows, every event's a probability, and that's the way the nature works. Then if you cannot predict next event, can we have a science? Yes. If it's become important to predict the chance of the event. For example, toss a coin, predict heads, how many heads is going to come out. It's going to show up half of the time. The tail, same way. Is there anything else going to show up? Well, yes, if coins stand up, but we don't count that kind of event. We toss it again. Okay, so that's a kind of agreement. We cannot predict that it will be in the next what it will be in the next toss. We cannot tell it's going to be head or tail, but we can tell the chance of being head or tail. That's the science of probability, and actually it's a math tool is what you learn here. So the condition of prediction is coin is uniformly made, right? It's not bent. So head and tail will be half chance. If you throw a die, it has to be balanced die. One side cannot be heavier than other side. So each number will be 1/6 of chance for each number. Okay, then we can predict what happened when you throw. Again, you cannot predict what it will be next, but you can predict what the chance will be. Throw it in a way that the outcome is random each time. So you have to throw it away. If you study very hard how to throw to get the desired result, that's what the gambler does. Somewhat they can do. They can influence the outcome. Okay, then it's not the even chance anymore. There's no historical dependency. If you throw many times and you practice and you start gaining experience to get the desired outcome, and that's called the historical dependency, and we exclude that. And prediction is not for it's for the infinite number of trials. Okay, it is possible to get 1,000 times head only or tail only. Okay, nothing wrong with it. There is a finite chance that you get 1,000 times head only. Very small, but you could, right? So what we are predicting is if you repeat it infinite number of times, okay, that's the prediction we're talking about. And you may misunderstand, right? You say, oh, it's already 10 times head, so I'm gonna bet on tail next time. Well, good luck. It could be another head. Okay, so the throw 3 dice, predict the chance to get this is wrong. 2 dice, predict the chance to get 7. Okay, so how do you handle this? You can predict using math. Okay, any combination such as 6 and 5 or 5, 6, 4 and 6. this is obviously wrong. 3, 7, 5, 2, 6, 1, 3, 4. Okay, so that gives you 7, right? There are 3, but it can be 2 dice are not distinguishable, so it could be 2, 5 instead of 5, 2, 1, 6 instead of 6, 1, so on so. So we have total 6 chance. And now the chance to get a certain number like a 5 is 32, and this is 1, 6, 1, 6, 1, 6, 136. Total combination of dice, the die 1 and die 2 has 1, 2, 3, 6, 1, 2, 3, 6. This combination 36. So one particular number you get, the chance is 136, and you have a 6 particular case, so 6 times is going to be 6 over 36. So what we did here is you count all the possible combination, and how many are the event that satisfy the condition. So number of event okayed, that means satisfied, and total number of event, right? So in this case 36, this is a 6, so that's gonna give you probability. Next question is, when 3 dice are thrown and add the numbers, what is the chance of getting the even number? Okay, so what we do is we may get even and even and even, right? Or odd and even. That gives the even number, right? But this one you can get odd and even and odd too. This is the die 1, 2, 3. The way we get is it could be even and odd and odd. So the chance to get even is half, right? And odd is half too. So times, and we have 4 ways to do this, right? So 1/2. So half of time we get the even number. Okay. Now we talk about dependent event. When an event result depends on the result of the previous event, it is a dependent event. Here's an example. We take a ball from a bag, we put it back in the event, then the next event will be the same condition as the current condition. In this case, event will be independent. If you do not put the ball back in the bag, the next event is different. In this case, we have a dependent event. Okay, so suppose we have 3 balls. One is red and the other is black, right? And you take one out and say it's happened to be red. If you take it back, next time the same chance. But when you get the red, and what is the next chance to get the red? It's 0 if you don't put this red back. back to the bag. So what's happened is this is going to be dependent. Okay, so dependent is when you ask what is the chance of getting red first time and black second time, and between them do not put the ball back. So the first time you get 1/3 chance to get the red. Second time, if you don't put it back, it's 0. I mean 100%, 1. So times 1 is going to be 1/3. Okay. But if you say the question, what is the chance that you take twice and get the red? Okay, and the condition is you do not put the ball back. So first time red can be 1/3, right? Then black will be 2/3. The second time you get the red is half, since one black is out. And after that, black is 100%. It doesn't matter second time because you get the red. So you have 2 cases. Okay, so it's going to be plus two-thirds. So if you take ball twice, the chance to get the red is 2/3. Okay. When we put it back, we repeat it r times the number of possible number sequences will be the sequence. Now you learn the sequence and the combination in the algebra. So this is going to help to count the number of cases. But often it's a very complicated cases. So often you have to break it down like this. Next example, find the permutation of following cases. 5 numbered ball and 1 gold ball are in a bag, so total 6. We take 1 ball at a time. Only when we get the gold ball, we take 1 more ball from the bag and put the gold ball back. How many different sequences are possible? Does this contain the dependent event? Yes, it does, right? This is a challenging question. Okay, the answer is here. So why don't you spend time and try to figure out this? Okay, this is quite a challenging question. In the high school, they do this, especially like Japan, China's college entrance exam. They give this kind of question. There are 5 wheels on the stage. On each wheel has the number 0 to 6. 5 numbers, 5 wheels on the stage, and each wheel has 0 to 6. So you have 5 wheels. Spin each wheel and get the number from the wheel. How many combinations are possible for 5-digit number from the wheel? That's easy, right? That's an independent event. Winner will be any number that contain 4 of the same digit. How many winner will be? Does this contain dependent event? No, it's all independent. All wheels are independent. So it's just combination problem, right? Okay, here's another challenge. Try it. Here's the answer. Okay. Now we talk about statistics. Otherwise, we have to split the video into probability and the statistics. Statistics objective is to predict the trend and tendency. Okay, trend and the tendency. Okay, now you look at this graph. There is a definition of the word means, mean, and median. Okay, they are different. Median is the left side number. Each value is called sampling. Say x is 1, 2, 3, 4. The sampling of x4 is say 1, 2, 3. 3. Sampling is like a function value. Sampling is a function value, but you can do discrete function because x can be discrete 1, 2, 3, 4, so and so. Okay. Then total number of sampling on the left side and the right side becomes same. That's called median. This line. But average is different. Average is most likely number, the x number. Okay. And standard deviation. There is a standard deviation. The standard deviation is how the sampling is clustered together around average with right x bar. It could be this way. Then this standard deviation is low. This one is high. Deviation, that's a deviation. And the way you calculate it, we standardize. So it's called standard deviation. And we use a sigma. Now, how you define the average? If it's a discrete value, x1, say it's age. The x can be 16, 17, 18, and 19. And sampling is 2, 3, 5, 2. So what you do is you add up this age, right? All of them. The I is the number of sampling, N is the total number of sampling. Okay, total number of sampling. So 16 times 2, 17 times 5, 18 times 5, 19 times 2, and divide by total number of sample. How many people? That's average age. Okay. If x is continuous function, so we define the probability function fp. Okay, fp is the probability of x being certain value. Okay, and if you add up all the probability, is total 1. So integral dp is 1. Okay, now average is x value, probability, you add them up. You don't have to divide it by this total number because probability function is made such a way entire summation is 1. Okay, now discrete value, we have a standard deviation, but standard deviation, before that we define variance. And the variance is what it is the xi, the age, and average x bar, the one you calculate here. So this shows the distance. So each value has some distance from the average value. Okay, and you add them up, all the distance square. Distance is square, right? D square, the distance. Okay, and divide by 1 over n minus 1. That's going to give a variance. And if you take a square root, it's a standard deviation for discrete x value. Now, this continuous function, x minus x bar and square, that's define the distance, and times probability, and you take integral, square root is a standard deviation, right? So you have to be careful though. It's not the average of the function. Average of the function is like a to b. You have like that. What is the average? You take an integral. That means you calculate this area, divide by the range. That gives the average. This is the average of the function. But this is the average of the sampling data. And sampling is used for the discrete data. And the continuous function, we don't say sampling. Instead, use the variable and the function. Okay? And do not get confused with this one. This is the average of function value. And this is the average of the parameter x. Okay? Now, statistics. One more important thing you should remember is correlation. Correlation is between two variables. For example, sun's black spot, stock market. They actually find a very strong correlation. That means they can tell by observing sun's black spot, then predict the stock market and try to make money out of it. Crazy, huh? Okay, there are some crazy people like that. So, correlation means when black spot increase, stock price goes up. This two relationship between two parameters, and it can happen, right? For example, frogs croaks, then more harvest on the crops. This is a negative correlation. If frogs is quieter, farmer will get the better harvest. And there is a certain correlation. I'm not saying this is correct. Okay? Correlation is not cause effect. It doesn't say cause and effect. Correlation is simply you put the data when frog croaks more this season and put the data harvesting. Okay? When there's no correlation, the data will scatter around. No correlation, zero correlation. This is negative correlation. This is the positive. For example, warning flag, storm warning flag. If the weather forecast people do very good job, correlation is very strong. Every time there is a warning flag, then storm come, right? And the famous story, they did that in a remote island. They put up the flag to warn the people storm's coming. But again, it's not the cause and effect, okay? Because native in the island thought, oh, every time that flag come up, then storm come. And they thought that flag must be calling storm. We have to take it down. They attack those weather forecast people and take down the flags. And no flags, no storm coming. That's what they thought, because they thought flag causing storm. Actually, reality, storm is causing flag. So this correlation doesn't tell you anything about cause and effect. Another example is drinking coffee and the cancer rate. When you drink more, cancer is reduced. Well, this correlation, you have to be careful. Even you see the correlation. For example, somebody said, you eat rice, you get cancer. And where did you get that conclusion? Well, I checked all the cancer patient eating rice. But like Japan, 90% of people eat rice. So most of the people who got cancer was eating rice. Is that the correlation? You may call that the correlation, but if you say you're eating rice, do you get the cancer? Probably it's doesn't matter you're eating rice or not. If you say you got the cancer, are you eating rice? Most of people say yes. So it's not really correlation. So it's very confusing. Correlation, is that really correlation or not? That's one question. Even it's correlated, which one is the cause and which one is the effect? It doesn't tell you. Okay? So the statistics and probability, the high school, they do a lot of probability, but statistics is just optional, and it's going to be the first year subject in the college. You just get some preliminary introduction here. Okay, I hope you enjoyed this video, and see you in the next video.